Ladies and gentlemen, welcome back to Theoretical Chemistry. I want to start with a real quick review from last unit because I know it's been a long time since we've been doing some of these problems, so I thought it'd be really nice to be able to work our way back into these types of problems with a real quick review. Now, if you remember way back, we said if we were given grams of a substance, let's say substance A, we could change those grams into moles of A using the molar mass of substance A. Now, using moles of substance A, we can change it into moles of B using, that's right, the mole ratio. Where does that ratio come from again? Well, that mole ratio comes from the coefficients in our balanced chemical equation. So from moles of one substance to moles of a different substance, we use the mole ratio, and if we so needed, we could change from moles of that substance back into grams of that substance using the molar mass of that new substance. So, just real quick overview, real quick review of our steps to be able to go from grams to moles, moles to moles, moles to grams, if our problem needs. Now remember to watch your units, follow your units. They are your road signs, they are your map. From point A to point B, they're going to tell you exactly where to go. So in this problem, we were given 25 grams of sodium, and your question word says how many grams of sodium fluoride are produced. Well, okay. We always start with our given. In this case, it's 25 grams of sodium, Na. So we know we're starting grams of sodium. Our question word was how many? We're looking for grams of sodium fluoride. Well, for this particular problem, we're starting in grams of a substance and going all the way to grams of a different substance. Well, if we look, we've got 1, 2, 3 arrows in there, which means we're going to actually have 3 conversion factors or 3 steps in our problem. Okay, if we're starting in grams of a substance, our first arrow says we go from grams to moles using the molar mass of A. If you find sodium on the periodic table, you'll find that for every 1 mole of sodium, there are 22.99 grams. Since our grams are on top right now, our grams must go on the bottom in our second step. They gotta. There's no ifs, ands, or buts. That's where they gotta go. Now we're moles of sodium. We are now here at moles of our first substance. We can now change it into moles of our different substance using the mole ratio. Well, the ratio between sodium and sodium fluoride is 2 to 2. Because we have sodium on top, we're going to put our sodium on the bottom for our next step. For every 2 moles of sodium, we've got 2 moles of sodium fluoride. Moles of sodium cancel. We're into moles of sodium fluoride. Now we're at moles of our new substance. We're close. We're so close. We've got one more step. We said we had 1, 2, 3 steps. We've got 1, 2 steps. We need to get to grams. So our final step is to go from moles to grams. We're going to use the molar mass of B. Well, our new substance is sodium fluoride. So we take a sodium, we add it to 1 fluorine. We find that the molar mass is 41.99 grams for every 1 mole. Well, we got moles on top right now, so that tells us our mole has got to go on bottom. Just gotta. And for every 1 mole of sodium fluoride, we have, as we said, 41.99 grams from the periodic table go on top. The moles cancel. The only unit you should have that hasn't canceled is the unit you're looking for. We're there. Final destination. You have reached your destination. So to solve, we're going to multiply the top, multiply the bottom, divide. When you divide those, you get 45.66 grams. But wait, sig figs. We started with 2 significant figures. This has got 4. Well, with 2 significant figures, looks like we want the first 2. The 6 is going to round the 5 up to a 6 as well. So our final answer would be 46 grams of sodium fluoride. Cool. Real quick review. If you want, go back and rewatch this. There are many other reviews on our YouTube channel as well. Feel free. If you have any questions, let me know.